For a time, Britain shied away from bold construction projects. We patched and mended and lived off the achievements of our Victorian forefathers. Then along came something rather special. What was it?
Well, I'm standing right on top of it now, St Pancras Station. The jewel in the crown of Britain's first major new railway in 100 years. And this country's first high-speed line.
It proved that when we put our mind to it, we can do large-scale infrastructure in the UK. And now there are grounds for thinking we're poised to rediscover our Victorian ambition. In the last programme, I looked at why Britain needs more infrastructure. Now, I'll look at how we're better placed to build that infrastructure than we have been for 100 years. We'll see some of the great engineering that confirms it, and we'll see what obstacles need to be overcome. Could we be heading for a new Victorian age for infrastructure in the UK?
This is St Pancras International.
It's ironic that St Pancras, a grand central statement of Victorian achievement in building infrastructure, also marked the start of a new era in 21st century construction, as the terminus of our first high-speed line.
All change, please. All change.
That line boasts the kind of engineering we thought we somehow couldn't manage. 150 bridges, miles of tunnels, and the longest high-speed viaduct in Europe. And the only way to experience it properly, of course, is to ride up in the front of the Javelin train.
Hello there.
Hello. Is this the passenger seat?
You
the
may sit there, yeah.
co-pilot seat?
You may sit there. Mind the little foot pedal below
Yeah.
you. And mind the red button there, because it causes unnecessary panic if you press it.
Right. Got your pre-flight checks.
Yes, all the cab checks have been done, all the brake testing has been carried out, and she's good to go.
London, Kent, to Paris and beyond. A line where trains reach speeds of 180 miles an hour. As fast as a Formula One car, but with a little more legroom. Well, it took a while before we got it, but here it is, Britain's first real high-speed line. What's great about being in the front of the train is you don't just get much more of a sensation of speed than you do when you're looking out the window from the side. You also just see how much has been built around this line, the tunnels, the bridges, the overhead power lines, the whole lot. Although only 100 kilometres long, it was far more ambitious than most high-speed lines elsewhere, with a fifth of it buried underground. Bridges, stations, listed buildings relocated, and the modernisation of St Pancras. And the building of some dazzling structures. This is where you can put your foot down a bit, right?
As well, we can give it a bit more power, yeah.
This is the Medway Viaduct, 1¼ kilometres of it. At the time, the longest single-span high-speed rail bridge in the world. It's where the trains on this line hit top speed. Passengers have fantastic views out of the Medway Valley, but only for a brief 15 seconds. Journey complete. I'm going to get off here at the end of the high-speed section of the line to talk to one of the really important individuals who was involved in building it. And what better place to meet than right under the Medway Viaduct itself?
Look at the spray just coming off it. raw power. This particular bridge is actually at the heart of what the project is about, which is sitting major infrastructure into the landscape. And this dominated a lot of our thinking about how we should design bridges for this project. And there are 150 of them. Medway is just one.
And then, 11 miles away, is probably the most challenging feature. The Thurrock Viaduct. It had to be fitted around existing infrastructure.
And that one's complicated because you're weaving a bit there, aren't you?
Oh yes, I nearly forgot the little complication of the Thurrock Bridge. We coined the phrase threading the needle.
Why threading the needle? Because when the high-speed line surfaces from its tunnels under the Thames, it becomes airborne and has to weave between the two carriageways linking the M25 to the QE2 bridge and the Dartford Tunnel. So they used a so-called push launch technique, and they built this 1.4 kilometre long bridge from one end and pushed it into place every fortnight for a year. And they did it barely disrupting the M25.
It's very difficult to conceive of any other technique that could have been used, which literally pushed the bridge over one carriageway and under the bridge of the other.
But what made High Speed 1 special was not the engineering, but the fact the project was managed and delivered relatively successfully. You see, building bridges, tunnels and stations is difficult. Each project is unique, inevitably involving a different assembly of owners, contractors and workers. And the trick to doing it well is to stop them squabbling with each other over money and instead getting them to work together. Easy to say, hard to do.
The attitudes that we realised we would have to change were the ones of collaboration rather than confrontation, so that everything was aligned as one project. It was their project, our project. It wasn't someone else's project. We all wanted it to be a success.
Which is more difficult? Is it building the thing, or is it organising the building of the thing?
Most certainly the most difficult task on a major project is alignment, is the alignment of people. Whether they be the community that you're consulting with, or the workers that are constructing it, or the designers that are trying to collaborate with each other. It is aligning them to the single message, which is the delivery.
Alignment, an engineering term that also applies to the task of managing people. Engineering the right mindset in humans is even tougher than designing bridges. It takes well-designed contracts and incentives.
I think when I was young, I just always assumed that we couldn't build stuff like this without it going wrong, being late, much more expensive than anyone thought.
I'm exaggerating slightly when I say this, but before HS1, large infrastructure projects were marked by large cost overruns, late delivery, and lots of conflict between the parties involved. After HS1, there is an attitude of collaboration, a recognition that by aligning people together, you achieve so much more. And that really is the key to the success of HS1 and the many projects which have followed it and those which will come into the future.
The train now standing at platform 11 terminates here.
You may not have known that High Speed 1 marked such a watershed for infrastructure in the UK, because when construction goes well, you don't really hear about it. There's no reason to.
But just across the road from St Pancras is an example of how difficult we used to make it for ourselves. The Great British Library cost 3 times what it was meant to. There were endless arguments over changes to the design. And it wasn't the only demonstration that we British had lost the knack of large-scale construction.
Go back 15 years, there was the Jubilee Line extension in London. It was late and expensive. Back a few more years, the Channel Tunnel cost almost twice what it was meant to and was a year late. It was marked by conflict between Eurotunnel and its builders. They argued for ages over who would pay for the cost of changes made to the work programme during construction itself. I could go on.
This station is monitored with closed-circuit television.
In all these cases, the engineering itself is astounding. People are impressed by these projects now. It's just they typify the fact that in Britain, construction has been expensive and unpredictable, as layers of contractors, subcontractors and workers fight over cost and reward. Our adversarial approach to business doesn't seem to have worked. And as if that wasn't enough, we've had another small problem too: politics.
Our political system is like our old construction business in being adversarial, and it has sometimes led to very bad decisions being taken about what to build.
When it comes to decisions, they don't come more spectacular than this.
This is the marvellous Humber Bridge. At nearly 2.5 kilometres, it was once the longest single-span suspension bridge in the world. Hull's answer to the Golden Gate. But I'm here because it offers a most striking contrast, an example of terrible human decision-making and yet such wonderful construction. We'll talk about bad politics later. First, though, the great engineering.
That is where I thought I was going, but it turns out the interesting bit of this bridge is down below.
Right. Whoa.
You just don't realise how much there is below. Roger, what a remarkable place to meet.
It's impressive, isn't it?
Serene here, isn't it?
It is. We're in the middle of a 200,000-ton block of concrete. Gives you some idea of the scale.
You could film a really good James Bond sequence in here. Whoa, look at those. Fantastic, aren't they? This is carrying the weight of the entire bridge.
Yes, but we're standing at one end of that main cable that goes across the river, which gives the bridge its distinctive shape. You can think of it as being a washing line anchored at the end, going over two clothes props, which is the towers, and then the bridge itself is the washing hanging on the line. This is where the clothesline is anchored to the ground.
These thick cables are each made of a thin piece of wire that travels 2.5 kilometres across the bridge and then back again 400 times. There are nearly 15,000 strands in all.
What about the road bridge itself? I mean, how stable is that?
This bridge tries to use the wind to its advantage. The route of the wind over the top of the bridge is shorter than the route underneath. So it's like an upside-down aircraft wing. Right. So as the wind blows, the bridge tends to move downwards, tight against the hanger ropes, flying on the air currents like washing on a line.
It's amazing to think how much underneath the bridge there is, the bit you don't see. But this isn't the only bit, is there?
The road deck is a hollow steel box, and you can walk the whole 1.5 miles through there from one side of the river to the other, inside the road deck.
That sounds like a challenge.
Have you ever walked through a bridge before? I won't get the full distance, but I can certainly get the measure of it down